Hi, my name is Chengxi, 12 years old. For this lesson, we'll be continuing on with another lesson for techniques and applications for definite integration. For this lesson of definite integration, we have this example over here whereas we have to find the volume in the first octant between the plane z equals to 0 and the curved surface is x plus y, z equals to x plus y plus 2, and inside the cylinder x squared plus y squared equals to 16. So first, what do we realize here is like this is definitely three-dimensional, something like this. So for this part over here, we have the first octant. So what is an octant? So over here we will have 8 octants, okay? So 8 octants, and which 8 are they? So for this part, the 8 octants, we have the first octant whereas x, y, and z are all positive. And then after that, we also, that is for the first octant. Then for our second octant, and it will be negative x, basically on this side, negative x, positive y, and positive z. Then after that, it will be at this side, the third octant is basically negative x, negative y, and positive z. And then the fourth octant is basically in negative y, positive x, positive x, negative y, positive z. And then the fifth octant will be positive x, positive y, and negative z. Then the sixth octant will be positive, negative x, positive y, negative z, and then after that over here we have negative x, negative y, and negative z over here. And last but not least, the eighth octant, and positive x, negative y, and negative z. So these are the 8 octants, and what we have over here is we only need the first octant, so it will just be for positive x, positive y, and positive z. Well, another way of thinking this is that, you know, the polar coordinates, we have the quadrants, right? Just three-dimensional. So you also have to include the z. So now that we have gotten this part, what will our graph be over here? So over here for this part, if you're talking about the whole graph, it's going to be here a cylinder because it's already written. That's one way to say it. So for this part, so what is the base for the cylinder? So you can tell that for this part, the curved surface is like over here. So the curved surface is basically for the z part and all. So this is basically the x, y, z, right? So we are going to, so for our z is basically, so the cylinder over here is going to be somewhere in the center. So as you can see for this part, it's going to be something like, so over here for this part, just a quick reminder that for this, it's going to be here at the center over here. So it's going to be something like, this, okay? And the curved surface over here, basically this part, the z equals to x plus y plus 2, right? So what we are going to have for this part, so we also have our x and y, which is the circle part, which is x squared plus y squared is equal to 16. And what does that show? So x squared plus y squared equals to 16 means that x squared plus y squared is 4 squared. Thus over here it's going to be a circle. So here 4, 4, negative 4 and negative 4. So this is for x and y. So for this part, we are finding the volume, right? But just because we are finding the volume does not mean that we must be using triple integration. In fact, you can use double integration or even single integration and all to solve the volume. You can use triple or single integration to solve for area and continues. Okay, it's like just because it is three-dimensional doesn't mean it's going to have triple integration. And because that over here it's only for the first octant, so we are only going to have the positive x, y, and z part. Okay, so what we're going to do here is, so we're going to use double integration in this example, although we're finding volume. So for this part, what can we tell? So over here, the volume is basically here for this part, which is for z, here dx, dy, okay? And then over here, what's our range? So over here we can choose to integrate with respect to x first or y squared. It's your choice, because that if you put this inside, which is going to be our next step, and we're going both ways you can solve it. So for this part, we're going to have I'm going to integrate with respect to x first. So when we integrate with respect to x first over here we're going to have wait, hold on a second. Like this. Okay, well, I forgot to write over here that x is basically equal to square root 16 minus y square. Okay, so this is our range for our boundary for x, and then our boundary for y is basically 0 to 4. Okay, so for this part over here, what we're going to have is, so once you equate over here, what we're going to have for j is basically x plus y plus 2. And thus we can already integrate for x. So when we integrate for x, what we're going to have is x squared over 2 plus xy plus 2x, and then from 0 to square root 16 minus y squared dy. And if you realize when you substitute 0 inside for all of these, you're going to end up with 0, so you can ignore it. And now we substitute this part inside, whereas we're going to have a 16 minus y squared over 2 plus y square root 16 minus y square plus 2 square root 16 minus y square, and then we're going to have dy. So what do we have here? So over here we have okay, so for this part, what you can tell already is that over here for this you can straight away integrate it for these two different terms and all. While for this part, even though you can't integrate it straight like this and all, but we can put this inside and we'll be able to integrate it. Well, on the other hand, for this part, let's just let it stay the same for now. So when we integrate for this, it's basically 8y from 0 to 4 minus, and then you integrate this y over y cubed over 6 from 0 to 4. Well, for this part, you put this part inside and you're going to get 0 to 4 half square root. So here you're going to have a half integral from 0 to 4, and then square root 16 minus y squared. So supposedly here it's supposed to be y squared, right? But let's make it the same. So here it's going to become a minus, and here it's going to become a 16 minus y squared. Well, for the 16 part, if you differentiate 16, it's going to become 0. So when you integrate the 0, it can be just any constant, or just stay at 0. So over here then, for this part, what we're going to have is, we're going to put it make it stay the same, because we can't do anything with it for now. Well, now over here, why don't we figure out a way to solve for this part already? So we are not going to substitute for these two parts since we can already calculate it. But for this part we can, because over here we need to, because otherwise we wouldn't be able to solve it. So what will y be equals to? So why don't we let y be equals to? So you'll see this minus part, right? So it would not be a tangent and all. So over here what we're going to have is going to be, you can choose sine, cosine, both are okay, but you must have a 4 in front. And here it's going to be 4 sine theta. Okay, let y be 4 sine theta, thus dy will be equals to, so you basically differentiate on both sides, and sine differentiation is just cosine theta d theta. And then what do we have here now? And then now that we have gotten this part, we also have to find so you need to find what theta is in order to find the boundary. So theta is basically inverse y over 4. Okay, so theta's boundary would be, so when y is equals to 4, it's going to be inverse sine 1, which is a pi over 2. Well, if you substitute 0 inside, inverse sine 0 will still be 0. So our boundary will be from 0 to pi over 2. Okay, alright. Now that we have gotten this part, we can integrate over here without this part subbing in, and we can just straight up just substitute the boundary inside. So here, when you times 0, you can ignore it because it will just be 0. So here will just be 32 minus this part. How you substitute 0? This part you substitute 4 cubed over 6 basic. So 4 cubed over 6. And then for this part, we integrate and we'll get 1 over 2 minus negative 1 over 2 times. So for this part, this is basically to the power of 1 over 2, right? So when you integrate it, it will become to the power of 3 over 2. So 3 over 2 you gotta take out, so it becomes 2 over 3 over here, and you substitute the boundaries from 0 to 4 inside. Then for this part, what we're going to have here is that we're going to substitute this part in, and we will get 2 times 4 because of the dy over here. Then integral from 0 to pi over 2 square root 4 square minus 4 square sine square theta. Then we have our cosine theta d theta. And now that we have gotten this part over here, what we're going to have is, so you can see these two simplify, and then this part you sub it in, you get 0, so minus this part will become positive and all, okay? So for this part, what it's going to become is, okay, now that we have gotten this part, what we can do now is, so over here, this when you sub in 4, 0, when you sub in 0, 16, so minus 1 over 3. So 16 is basically 4 squared, so when you square it, it's going to be 4. And here we are going to get a 4 to the power of 3. Okay. And here it's going to be a plus. So now that we have gotten for this part, for this what we're going to have is we can take out, this will become 4 square. Here you can take out the 4 square, which will, because here have square root, so we'll have another 4, so 4 times 8, 32, from 0 to pi over 2. So if you realize once you take out the 4 square, it's going to be 1 minus sine square theta, right? And since sine square has theta plus cosine square theta is equals to 1, so 1 minus sine square theta will be equals to cosine square theta, and since we have the square root, it's going to be cosine. And thus over here we have a cosine square theta d theta. So for this part over here, what we are going to have is 32 plus 32 over 3. Then plus, well over here these two kind of a minus, so 32 plus 32 over 3, then you plus. So what is cosine square theta? So cosine square theta is basically so 2 cosine square theta will be equals to 1 plus cosine 2 theta d theta. Okay, alright, so for this part, what we're going to get here will be (1 to 8 over 3), then plus this part. So when you integrate the front part, the term in front over here, you can integrate it already. So you just get theta from 0 to 2 pi over 2. And then for the behind part, you can also integrate it, just that it will become 8 instead, because that cosine 2 theta, so you need a 2 for the theta. Thus the 16 will become an 8, and cosine integration becomes sine 2 theta from 0 to pi over 2. Whereas over here, this part will stay the same, 1 to 8 over 3. Well, for this part, when you substitute the 0 inside, it's going to be 0, so you can just ignore it. And if you substitute the pi over 2 inside, it's going to become 8 pi. And when you substitute pi over 2 over here, because times 2, so it becomes sine pi, which is 0. And then for this pi, if you sub in 0, it will just be 0. So our result that we get for this lesson over here is that for the volume is basically so the volume is basically this part, okay, 1 to 8 over 3 plus 8 pi. Hi. So for this part over here, that'll be all for this lesson. What we mainly did was mainly the substitution part, and then we also had our sine square plus cosine square equals to 1, and then last but not least, the double angle formula. Okay, so that'll be all for this lesson. And take a quick look. Last but not least, thank you for your watching.